Hello friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace Transform. In today's lecture, we will focus on inverse Laplace transform. Now, definition of inverse Laplace transform. If Laplace transform of f of t is equal to f bar s, then the original function f of t is called an inverse Laplace transform of f bar s. That is, we return it as L inverse of f bar s is equal to f of t. So this is the inverse Laplace transform of f bar s. For example, now Laplace transform of e to the power at is equal to 1 upon s minus a, and therefore as per the definition, inverse of this 1 upon s minus a, therefore inverse of 1 upon s minus a is equal to this original function e to the power at. Now similarly, Laplace transform of t is equal to 1 by s square. Therefore, inverse of this 1 by s square is equal to. Now let us see shifting property for inverse Laplace transform. Now we recall cos shifting property for Laplace transform. If Laplace transform of f of t is equal to f bar s, then Laplace transform of e to the power at f of t is equal to f bar s minus a, and Laplace transform of e to the power minus at f of t is equal to f bar s plus a. Now, by using the definition of inverse Laplace transform, if inverse of f bar s is equal to f of t, then inverse of f bar s minus a, f bar s minus a is equal to this e to the power at times f of t, and inverse of f bar s plus a, and inverse of f bar s plus a is equal to e to the power minus at f of t. Now we write this as this is equal to e to the power at, and this f of t be the L inverse of f bar s. We write it as this f bar s minus a is equal to e to the power at inverse of f bar s, and L inverse of f bar s plus a is equal to e to the power minus at times f of t is equal to e to the power minus at inverse of this again f of t be the inverse of f bar s. This is the shifting property for inverse Laplace transform. Now, for example, inverse of s plus 1 upon s plus 1 whole square plus 2 square. Now this is equal to, now this s plus 1 upon s plus 1 whole square plus 2 square, this f bar s is in the form of f bar s plus a, and inverse of f bar s plus a, answer is e to the power minus at times L inverse of f bar s. Here this 1 be the a, therefore this is equal to e to the power minus at means e to the power minus t times L inverse of f bar s. Now f bar s be the s upon s square plus 2 square. Now inverse of s upon s square plus 2 square be the cos 2 times t, because s upon s square plus 2 square be the Laplace transform of cos 2 times t. So therefore inverse of s upon s square plus 2 square, answer is cos 2 times t. Now example 2, inverse of s upon s minus 3 whole square. Now this function, we write this function is in the form of f bar s minus a. For this we write L inverse is equal to this s. Now we write s minus 3 plus 3, that means s upon s minus 3 whole square. Now this given function is in the form of f bar s minus a, and therefore its inverse is equal to e to the power at. Here a is equal to 3, and therefore answer is e to the power at means e to the power 3 times t times L inverse is equal to L inverse f bar s. Here f bar s be the s plus 3 upon this s square. This is equal to e to the power 3 times t L inverse of, now dividing this s by s square plus 3 by s square means 1 by s plus 3 times 1 by s square, and this is equal to e to the power 3 times t. Now L inverse of 1 by s, the answer is 1 plus 3 inverse of 1 by s square, answer is t, and therefore inverse of s by s minus 3 whole square is equal to e to the power 3 times t bracket 1 plus 3 times t by using post shifting property for inverse Laplace transform. Now we recall the Laplace transform of some standard functions in the form of table. If f of t is equal to 1, then its Laplace transform be the 1 by s. Similarly, f of t equal to t, then f bar s means Laplace transform of f of t is equal to 1 upon s square. If f of t is equal to exponential function e to the power at, then its Laplace transform is 1 by s minus a. Similarly, if f of t is equal to e to the power minus at, then its Laplace transform is 1 upon s plus a. If f of t be the sin at means sine function, then its Laplace transform is a upon s square plus a square. Similarly, if f of t is equal to cos at, then its Laplace transform is s upon s square plus a square. If f of t be the sine hyperbolic function means sin h at, then its Laplace transform is a upon s square minus a square. If f of t is equal to cos h at, then this f bar s be the s upon s square minus a square. If f of t be the function t to the power n, where n be the positive integer, then its Laplace transform is n factorial upon s to the power n plus 1. If f of t be the t to the power a, and here a is positive, then its Laplace transform is gamma a plus 1 upon s to the power a plus 1. Now let us see inverse Laplace transform of some standard functions. Now if f bar s is equal to 1 by s, then its inverse be the 1, because Laplace transform of 1 be the 1 by s, therefore inverse of 1 by s, answer is 1. Now inverse of 1 by s square, answer is t, because Laplace transform of t, answer is 1 by s square. Now inverse of 1 upon s minus a, answer is e to the power at. Inverse of 1 upon s plus a, answer is e to the power minus at. Now Laplace transform of sin at, answer is a upon s square plus a square. So therefore inverse of 1 upon s square plus a square, answer is sin at upon a. We are adjusting this a. Inverse of s upon s square plus a square, answer is cos at. Inverse of 1 upon s square minus a square, answer is sin h at upon a. Inverse of s upon a square minus a square, answer is cos HAT. Inverse of 1 upon s to the power n plus 1, answer is t to the power n upon n factorial. Here n is positive integer. Similarly, inverse of 1 upon s to the power a plus 1, answer is t to the power a upon gamma a plus 1. Here a be the positive. Because Laplace transform of t to the power a, answer is gamma a plus 1 upon s to the power a plus 1. In the upcoming lecture, we will find inverse Laplace transform by using convolution theorem, partial fraction method, and by using properties. At that time, this table will be helpful to you definitely. Please subscribe the channel and let me know your comment and feedback. Thank you. Have a nice day.